In this video, we'll start talking about what a derivative is and then work out a formal definition. Say you have the function shown, x over 2 squared. Say this function represents the vertical position of a moving target on a screen as a function of time, and we want to know the target's instantaneous vertical velocity right at t equals 1 second. What we want is the rate of change of vertical position per unit time when the target is where it is at t equals 1 second. What we want is the slope of the tangent line that touches this function at 1, 0.25. This is what the derivative is. Now when we have 2 points on a curve, finding the slope of the secant line that connects the 2 points is simply the ratio of the rise over the run. If point P1 has the coordinates x1, y1, and a point to the right of P1 called P2 has the coordinates x2, y2, the slope of the secant line is y2 minus y1 over x2 minus x1. If the function is y equals f of x, then the difference equation can be written as f of x2 minus f of x1 over x2 minus x1. We can also imagine that instead of specifying the value of x2 directly, we can say that x2 is a position on the x-axis some distance h to the right of x1. Or in other words, the x-coordinate of the point on the right is x1 plus h, and its y-coordinate is f of x1 plus h. As you can see, the x1's cancel out in the denominator, and the difference equation becomes f of x1 plus h minus f of x1 over h. What we can do is change the value of h to move P2 further from or closer to P1. Watch what happens as we move P2 closer to P1 by decreasing h. As h approaches 0, the slope of the secant approaches the slope of the tangent at P1. So the derivative of the function f, which is sometimes written as f prime of x, and sometimes as dy dx, among other notations, at the value x, is the limit as h approaches 0 of f of x plus h minus f of x over h.